Okay, so कल के लेक्चर में हमने ऑलरेडी कुछ MCQs किए थे. So let us move further. Yes, I hope you can see the screen. This is the last MCQ we have just solved. Let us go to the next. Yes. Consider this first question here. Read it carefully. What will be the of the image when an object of 2 millimeter is placed at a distance of 20 centimeter in front of an axis of a convex mirror of radius of curvature 40 centimeter. Okay, so see here, we want to find out the height of the image when an object of 2 millimeter is placed at a distance of 20 centimeter in front of axis of convex mirror. So there is a convex mirror. Suppose ये convex mirror है, उसका ये वाला surface जो है वो opaque है. Okay, and the object is going to be at 20 centimeter along its axis. So can just show the object at this point here. ये यहाँ पे object रहने वाला है. और ये distance जो है तो वो 20 centimeter दिया हुआ है already. Okay. And then the image height is already given to be 2 millimeter here. Okay, this is the image height given here, and now we want to find out the height of image. Yes, height of image. So in order to do that, we'll have to use the formula, and it is it is given that the radius of curvature of this convex mirror is going to be 40 centimeter. So since radius of curvature is 40 centimeter, we already know that in case of a mirror, the focal length of the mirror is always going to be r/2, right? तो ये r/2 यहाँ पे हमको मिल जाएगा, और 40 को अगर 2 से डिवाइड करेंगे तो सिंपली हमको 20 मिल जाएगा. So this 20 centimeter is going to be actually the focal length of the convex mirror. Yes, and we have the formula, mirror formula, which tells us that 1/v plus 1/u to be found out. So we can just get that 1/v plus 1/u. U is going to be -20 actually, because this u is at the left side. Okay, so that's why it will be -20 here, and which is going to be equal to 1/f, where f is going to be +20, because it's a convex mirror. Convex mirror का जो है, convex कोई भी हो, mirror हो या lens हो, focal length हमेशा उसका positive ही लिया जाता है. इस -1/20 को उस तरफ शिफ्ट कर देंगे, जिससे हमको मिलेगा 1/20 plus 1/20 once again, which happens to be actually 2/20, and 2/20 मतलब 1/10. So since this 1/v is equal to 1/10, it means v must be equal to 10. So v is obtained to be equal to 10 here, 10 centimeter. Okay, so once we get this v, we can get the image height also just by using the formula for magnification. Magnification of a convex lens, convex mirror, is always given by one formula is actually, basic formula is h'/h, and which should be equal to v/u. So if we just use it here, then h' is to be found out, and h is given to be 2 millimeter here. So this is 2 millimeter, and v is actually 10. Okay, and u is already -20. Okay, so if we just solve this further, then we'll be able to get this h dash. Sorry. So ये 0 0 cancel हो जाएगा और h dash becomes actually equal to, the minus sign is already here. And hence h dash becomes actually equal to 2, ये 0 0 cancel, 2 2 cancel, 1 millimeter here. So 1 millimeter will be actually the final answer, which is already there in this option number D here. Okay, not 10 millimeter, should be 1 millimeter. Okay. Are you getting this? Or if you have any doubt, you can just ask. Okay, let us move to the next question then. Second question that is here. Yes. Focal length of objective and eyepiece. See here, the focal length of objective and eyepiece of a telescope are 200 centimeter and 4 centimeter respectively. What is the length of telescope for normal adjustment? Okay, that means, see, the focal length of objective, we can call it as FO here, is given to be 200 centimeter. And at the same time, the focal length of eyepiece, we can call it as FE here, that is given to be 4 centimeter, correct? And then what is the length of telescope for normal adjustment? It's very simple question. The length of telescope always is going to be the sum of, and if we just add these two up, then we can just be able to get this 200 plus 4, which happens to be simply 204 centimeter. That's all, which is already there in option number D here. It's just memory based question or just oral question, we can say. Let us see the next one here. An astronomical telescope has a magnifying power. Okay, astronomical telescope has a magnifying power of 10. The focal length of eyepiece is 20. Then what is the focal length of objective? Okay, so like focal length of eyepiece is given to be 20. That means this 20 given here is going to be FE here. Okay, FE is given to be 20 centimeter. And the focal length of objective is to be found out. Okay, and power, magnifying power of this astronomical telescope is already given. So we can just say magnifying power of telescope is given to be 10. But already we have seen that the magnifying power of a telescope is always equal to the ratio of the focal length of objective to the focal length of eyepiece, correct? So if the ratio of these two is given to be 10, so we can just get this 10 to be simply equal to FO, which is to be found out, and FE, which is given already, that is 20 centimeter. So if we just multiply these together, then we can be able to get this FO to be simply equal to 200 centimeter. Remember, so this will actually be the focal length of objective here. Okay. Yes, very good. See the next question. Yes, the magnification produced by objective of a lens and eye lens of compound microscope are 25 and 6 respectively. The magnification of microscope is, okay, just multiply these 25 as well as no need to take it on the board. You can just solve it here only. See here, magnifications of compound microscope में दो लेंस होते हैं, एक ऑब्जेक्टिव और एक आई लेंस. ऑब्जेक्टिव का दिया हुआ है मैग्निफिकेशन 25 और दूसरी तरफ यहाँ पे आई लेंस का जो मैग्निफिकेशन दिया हुआ है वो है 6. सो इफ यू जस्ट मल्टीप्लाई दिस 25 with 6, we can get this 150 as a final is going to be the correct option here. Let us see the next question, fifth one. The magnification at least distance of distinct vision of a simple microscope having its focal length 5 centimeter is, yes. मैग्निफिकेशन एट लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन, मतलब मैग्नीफाइंग पावर एक्चुअली वहां पे पूछना है. तो सिंपल माइक्रोस्कोप के बारे में हमको पता है ऑलरेडी. सिंपल माइक्रोस्कोप एक्ट्स एज अ convex lens acts as a simple microscope when the object is placed within the focus. Okay, तो फोकस के अंदर अगर जब ये रखा जाए तो अब फोकल लेंथ कितना दिया हुआ है, 5 सेंटीमीटर दिया हुआ है, 5 सेंटीमीटर. और इस केस में ये जो मैग्नीफाइंग पावर है, मैग्नीफाइंग पावर ऑफ सिंपल माइक्रोस्कोप, वो एक्चुअली होता है d अपॉन, लेकिन जैसे कि यहाँ पे हमको पता है u इज नॉट गिवन हियर, बट this can be proved to be equal to d upon v plus d upon f actually, and it can also have two extreme values. We already have proved in the theory that minimum it can be simply d upon f. This happens only when the image is at infinity, and the magnifying power happens to be actually to be equal to 1 plus d upon f here, and this happens only when the image is formed at distance of distinct vision. And this is the case which is mentioned here, because see here, the magnification at least distance of distinct vision. तो ये जो है इससे हमको पता चलता है कि the image is going to form at distance of distinct vision, and that's why we have to use this formula here in this case. Okay, 1 plus d upon f, and if we use that, then we can just get the magnifying power of that compound microscope, simple microscope, to be simply 1 plus d upon f, where d is going to be 25 as we know already, and this f is going to be 5 centimeter here. So if we just add this, so 1 plus 5, it comes out to be 6 actually, and hence we can just get the magnifying power to be simply equal to 6, which is already there in this option D here. Yes, correct. Let us see the next question. Okay, for compound microscope, okay, for the compound microscope, FO is 1 centimeter given here, and FE is equal to 2.5 centimeter given. An object is placed at a distance of 1. What should be the length of microscope for normal adjustment? Okay, अभी ठीक है. Normal adjustment का मतलब क्या होता है, समझो ठीक से. Normal adjustment means the infinity पे image should be formed at infinity, not at distance of distinct vision. The image should be formed at infinity, then we can call it as a normal adjustment. Okay, so here compound microscope के बारे में हमको ये पता है already कि this is the suppose objective and this is the eyepiece here. Both of them are on the same axis like this here, and object is placed at the distance of 1.2 centimeter here. यहाँ पे ऑब्जेक्ट हमने रखा हुआ है जिसका डिस्टेंस यहाँ पे 1.2 सेंटीमीटर दे रखा है. ठीक है, दिस डिस्टेंस इज ऑलरेडी गिवन टू बी 1.2 सेंटीमीटर हियर. ओके, ये एक्चुअली हमारा 1.2 सेंटीमीटर है. ठीक है, इसको हम u बोल सकते हैं. ओके, एंड देन FO is already given. Okay, FE is also given. Yes, so since the final image is going to form at infinity, what does it mean? So the final image is formed at infinity. That means the object of this, ये इसका first object का जो image है तो वो यहाँ पे फोकल लेंथ पे फॉर्म हुआ होना जरूरी है, तभी जाके फाइनल इमेज इंफिनिटी पे फॉर्म हो सकता है। ओके, और वैसे भी फॉर्मूलेज है, तो इसके अंदर कंपाउंड माइक्रोस्कोप के बारे में जो फॉर्मूले बनते हैं वो सबसे बेसिक फॉर्मूला हमारे पास क्या है, तो वो मैग्नीफाइंग पावर ऑफ कंपाउंड माइक्रोस्कोप एक्चुअली हैपेंस टू बी द magnification produced by objective multiplied by the magnifying power of eyepiece, correct है, magnifying power of eyepiece we can say। तो मैग्नीफाइंग पावर को हम कैपिटल एम से डिनोट करेंगे और मैग्निफिकेशन को स्मॉल एम से डिनोट करेंगे, और इनके अगर फॉर्मूले हमने यहाँ पे डाल दिए तो हमको मिलता है इधर BO अपॉन UO एक तरफ, और इस ME के बदले हम दो वैल्यूज डाल सकते हैं। एक तो एक्चुअली वो D अपॉन UE के बराबर मिलता है, लेकिन ये जो D अपॉन UE है तो वो या तो D अपॉन FE बन सकता है या तो 1 प्लस D अपॉन FE भी बन सकता है, डिपेंडिंग अपॉन whether the image is formed at infinity or at distance of distinct vision. So this will happen only the image will be formed at distance of distinct vision, and this will happen if the image is formed at infinity. But बाकी V upon U जो है, V naught upon U naught, वो वैसे ही रहने वाला है, it is not going to change, it's going to be the same actually. Yes. तो अभी यहाँ पे इसमें देखो ठीक से कि अभी इसमें जो केस यहाँ पे हमको दिया हुआ है कि नॉर्मल एडजस्टमेंट के बारे में बोला हुआ है, तो नॉर्मल एडजस्टमेंट का मतलब द फाइनल इमेज इज गोइंग टू फॉर्म दैट इंफिनिटी, दैट मींस दिस इज गोइंग टू बी द केस हियर, so we have to use the formula for magnifying power, but magnifying power is not given actually here. Okay, तो ये तो हमको पता है कि this is going to be the case finally. Okay, so ठीक है 2.5, जिससे हम ME तो निकाल सकते हैं। We want to find out the length of telescope actually. Okay, see here, length of telescope is going to be actually the sum of the, actually it is the sum of VO, right? VO and UE actually, UE, right? But since the final image is going to form that infinity, so UE is going to be the same as FE here in this case. समझा क्यों? तो फाइनल इमेज इंफिनिटी पे फॉर्म होने वाला है, तो इसलिए UE और FE सेम ही रहने वाला है। ये बात समझो इसमें ठीक से, क्योंकि जब फाइनल जो ऑब्जेक्ट जो है तो वो अगर फोकस पे रहेगा तभी तो फाइनल इमेज इंफिनिटी पे जाएगा, है कि नहीं? तो इसलिए ये ऑब्जेक्ट यहाँ पे ऑब्जेक्ट फोकस पे रहने के लिए इसका जो फोकल लेंथ है FE, वही उसके ऑब्जेक्ट का डिस्टेंस होना जरूरी है। दैट मीन्स UE मस्ट बी सेम एज FE। ओके, तो FE तो हमको ऑलरेडी दिया हुआ है, बाकी रही बात VO का, तो VO हमको निकालना है। VO can be found out, and once we get this VO, finally we can just use this formula, L is equal to VO plus UE or FE here. Okay, actually it is UE, but since the final image is formed at infinity, UE, that's why the length of telescope is going to be obtained by using this formula, but this VO here is going to be missing, right? So VO is going to be missing. In order to find out this VO, okay, so VO फाइंड करने के लिए हम यूज करेंगे यहाँ पे हमारा मिरर लेंस इक्वेशन फॉर दिस फर्स्ट लेंस, ऑब्जेक्टिव लेंस के लिए हम यूज करेंगे इसको। ओके, सो इफ यू जस्ट यूज इट हियर, देन वी कैन गेट दिस 1 upon VO minus 1 upon UO is equal to 1 upon FO, right? So 1 upon VO minus 1 upon UO. UO is given to be 1.2 centimeter, but don't forget to take it negative. So it will be minus 1.2 here actually, which is going to be 1 upon FO. FO is already given 1 centimeter here. And if we just put it here, then we can just be able to get 1 upon VO is equal to, sorry, 1 upon VO plus 1 upon 1.2, which is going to be equal to 1. So 1 upon VO actually happens to be 1 minus 1 upon 1.2, which happens to be So 1 upon VO is equal to 1.2 minus 1 upon 1.2 itself. And hence we can get this finally as 1 upon VO to be simply equal to 0.2, okay, 0.2 upon 1.2, correct? That means 1 upon VO should be 2 by 12. Okay, so 2 by 12, and 2 by 12 means 1 by 6, right? So since 1 upon VO is equal to 1 upon 6, so VO should be equal to 6 centimeter here in this way. Okay, so once we get this VO, we can just put it here in this formula and get the length of microscope as a final. So the length of telescope will be VO plus FE, 2.5 centimeter here. So if we just put it here in this way, then the 6 plus 2.5 comes out to be 8.5. That's it. So this is actually going to be the length of microscope, which is found out here. So 8.5 centimeter, which is there already in option A here, will be the correct one. Yes, Athar, very good. You are already solved it before. Yes. If you want, just observe this carefully. And if you have some doubt, you can just put it in the chat box. Just go to the next question. Okay, so let us go to the next question. 7th question here. Yes. An eyepiece of focal length 10 centimeter, an objective of focal length 4 centimeter. Okay, that means what is given here is, see, FE is already given. Okay, FE is given to be 10 centimeter, and the objective का focal length FO से denote किया जाता है. That FO is already given to be 4 centimeter here. Okay. Calculate the magnification if the object is kept at a distance of 5 centimeter from the objective, so that the final image is formed at the least distance of distinct vision of 20 centimeter. Okay, so that means okay. So once again, we have to draw the diagram of compound microscope here. This is your compound microscope. Objective, eyepiece, focal length of both of them are given already, and it is given that the final image is formed at least distance of distinct vision of 20 centimeter here. That means final image is formed at distance of distinct vision. Once again, we have the formula for magnifying power of this compound microscope to be simply the product of magnification produced by objective multiplied by the magnifying power of eyepiece here, and magnification produced by objective is VO upon UO, no doubt, but magnification produced by objective has two cases, and one of which is 1 plus D upon FE. Okay, so 1 plus D upon FE, and this case has to be used here just because the final image is going to be formed at infinity. नहीं, sorry, distance of distinct vision पे final image form होने जा रहा है, इसीलिए यहाँ पे हमको okay, so VO upon UO is into 1 plus D upon FE is to be used here because the final image is going to be formed at distance of distinct vision here. Okay, तो इसलिए ये वाला फॉर्मूला आपको यूज करना होगा. Yes, but यहाँ पे देखो FO FE तो दिया है already, but we object का distance भी दिया हुआ है already. ये देखो 5 centimeter. That means the object is going to be at this point here, which is at 5 centimeter away from the objective. That means UO is also given. Okay, UO is given. VO is to be found out. तो देखो यहाँ पे UO is going to be -5 सेंटीमीटर. VO फाइंड करने के लिए हम क्या करेंगे? लेंस इक्वेशन यूज करेंगे for the objective only. So it will be 1 upon VO minus 1 upon UO is equal to 1 upon FO. So 1 upon VO minus 1 upon UO. UO is -5. So here -5 is put as it is, which is going to be 1 upon FO, which is 4 here. And if you just solve this further, then we can get this 1 upon VO plus 1 upon 5 is equal to 1 upon 4, which means 1 upon VO must be equal to 1 upon 4 minus 1 upon 5, which gives 1 upon VO to be simply equal to, यहाँ पे LCM ले लो तो हमको मिलेगा 5 minus 4 upon 20, which gives 1 upon VO is equal to 1 upon 20. That means VO should be equal to 20 centimeter. Okay, so VO हमको मिल गया. Once you get VO, we can just use this value here in this formula. तो MP निकालने के लिए हम ये वाला formula use कर सकते हैं आराम से. So in the next step, we can just get this MP finally, that is magnifying power of compound microscope, to be simply VO upon UO into 1 plus D upon FE here. And why we are using this formula? Because it is mentioned here that the final image is going to be formed at least distance of distinct vision of 20 centimeter. Okay, so that is also given. Normally it is 25 centimeter actually, but here it is given to be 20 centimeter. It's okay. So you can just get this UO, which is going to be 20 upon UO, which is 5, and then multiplied with 1 plus D, which is 20. That is to be divided by FE, which is 10. So if we just calculate this finally, तो यहाँ पे आ जाता है 4 और यहाँ पे आ जाएगा 1 plus 2. Okay, and this 4 into 3, it comes out to be 12, which is already there in this option A here, which should be the correct one. Okay. Yes, let us see the next question. Eighth one. A convex mirror forms a convex mirror forms an image which is 1/4 the size of object. If object is at a distance of 0.5 meter from the mirror, then the length of the mirror is So convex mirror forms an image 1/4 of the size of object. What does it mean? ये suppose convex mirror है और इसके सामने ये ऑब्जेक्ट हमने रखा है. ओके, तो इसके 1/4 साइज का इमेज यहाँ पे फॉर्म होता है, ये दिया हुआ है. सो इट मीन्स दैट द साइज ऑफ इमेज is going correct है. Yes, so that means the ratio of size of image to the size of object is going to be 1/4, which also means that because this ratio is also equal to V upon U, right? So you can just have that this V upon U is also going to be 1/4, which means 1/4 of U. Okay. So if an object is at a distance of 0.5 meter from the mirror, that means U is already given. Okay. So if U is given,